All right, let's get right into it. If you're a beekeeper, you know that every spring feels like a race against the clock. The big goal? Getting your honeybee colonies to just explode in population. It's a make or break challenge that really sets the stage for the entire year. And this population boom, it's not just for looks. It's the engine that drives the whole operation. You need a massive workforce of bees to bring in enough nectar for honey, and, just as important, to have strong colonies ready for those crucial crop pollination contracts. So what's the fuel for this incredible growth? Well, nectar gives them carbohydrates for energy. You can kind of think of it as their sugar rush, but it's the pollen that provides the real building blocks. Pollen is packed with the protein, fats, vitamins, and minerals they absolutely need to raise their young. And, that brings us to the big question for beekeepers. What do you do when nature just doesn't cooperate? Maybe it's a late spring or bad weather, or the landscape around you is poor, and there just isn't enough natural pollen. How do you step in? And more importantly, what's the best way to do it? Before we jump into a really cool experiment that tried to answer that question, we need to get a handle on the basics of bee nutrition. And it really all comes down to protein. See, just like us, bees can't just create protein out of thin air. They need these specific little building blocks called essential amino acids. And the essential part is key. They have to get them from their food. If even one of those 10 is missing, their ability to grow just grinds to a halt. There's a fantastic analogy that scientists use for this, and it makes the whole concept super clear. I want you to picture a wooden barrel, but the wooden slats, the staves, are all different lengths. Okay, so in this picture, each one of those staves is an essential amino acid. The water you're pouring in, that's the colony's potential for growth. You could have tons of 9 amino acids, 9 really high staves, but if that 10th one is short, the water just pours out. The growth is limited by that one single nutrient. Now here's where it gets tricky. That short stave can be different depending on what the bees are eating. Natural pollens, for example, are often low in certain amino acids, while commercial feeds might be low in completely different ones. This makes supplementation a really complex puzzle, because you might be trying to plug leaks in 2 different barrels at the same time. So, to try and solve this puzzle, researchers in the Canadian prairies set up this big, multi-year experiment. The goal was to figure out, once and for all, which commercial protein supplement, or patty, was actually the best for bees coming out of a long winter. The plan itself was pretty straightforward. They took a bunch of bee colonies, fed them different commercial patties for a few weeks, carefully measured how much the bees ate, and then tracked how much the colonies grew. Simple enough, right? And they tested a whole range of products. These were the contenders. You had patties using traditional stuff like pollen and soy, and others using more modern ingredients like yeast or even algae. The point is, there's no single recipe everyone agrees on. Every company has its own secret sauce. So the researchers gathered all their data, and right away, things got a little weird. The results actually created a scientific puzzle that took them years to finally figure out. So the first thing they found was pretty obvious. Bees are picky eaters. They absolutely devoured some of the patties and barely touched others. So you'd think, okay, case closed. If they eat more of it, it must be better for them, right? Well, hold on. This is where the puzzle really begins. Because even though they ate way different amounts of the patties, all the colonies that got fed grew at almost the exact same rate. Eating more did not mean more growth. So this was the big contradiction that had everyone scratching their heads. How on earth could bees eat different amounts of different foods and all end up with the same population growth? What was the missing piece here? The next year, the researchers added an unfed control group, and the results were, wow. Really stark. The colonies that were fed anything at all produced way, way more young bees, that's the brood, than the poor unfed group. So this proved that yes, feeding was definitely helping. But it still didn't explain why the type of feed didn't seem to matter. It turns out the final piece of the puzzle, the thing that explained everything, wasn't inside the patty at all. It was outside the hive, in the landscape itself. See, the researchers realized that 2018, that first year of the study, was a good pollen year. A late spring meant that when the bees came out, there was a buffet of natural pollen waiting for them. But in 2020, they deliberately moved the experiment to a bad yard with almost 0 natural pollen. And that explains everything. This chart here shows something called feed efficiency. Basically, how many new bees you get for every gram of patty eaten. In that good pollen year, 2018, the efficiency looks crazy high, Why? Because the patty's performance was being massively subsidized by all the high-quality natural pollen the bees were also eating. The patty was just a supplement. But in the bad years, when the bees had only the patty to rely on, its true, much lower nutritional value was revealed. So here's the bottom line. When your bees have access to good natural food, pretty much any decent supplement will give them a boost. The patty is just topping them off. But when there's nothing else out there, they are completely dependent on what you give them. And that's when the quality of that patty becomes absolutely critical. Okay, so what does this all mean for a beekeeper on the ground? Well, this research really boils down to a few key rules for how to think about feeding your bees. Rule number 1 is a big one, especially in northern climates. Spring feeding isn't just nice to do, it's essential. Just look at this number. In the study, fed colonies had 6 times more developing brood than unfed colonies in just 2 weeks. That is the difference between a booming colony and one that just fizzles out. And that leads us to rule number 2, which the lead researcher, Dr. Shelley Hoover, summed up perfectly. She said consumption does not equal benefit. Just because your bees are gobbling up a patty, it doesn't mean it's the best one for them. They might just like the sugar or the texture. The real test is colony growth. And this all comes back to a final crucial point. You have to know your landscape. The feed you provide is only one part of the nutritional equation. And really, that leaves us with a much bigger question to chew on. This whole debate about the perfect bee feed, it shines a light on a deeper issue, doesn't it? If our bees are becoming more and more dependent on these artificial diets, what does that really tell us about the health and the diversity of the very landscapes we're all counting on to support them?